Imagine a world where giant deserts stretched farther than the eye could see, where rivers twisted through scorched plains, and where forests gasped for survival under a relentless sun. This was not a distant planet, nor a scene from science fiction. This was Earth, about 260 million years ago, during the final chapters of the Permian period. But within this ancient world, a storm was brewing, destined to reshape the history of life. The creatures that roamed these lands, from mighty tusked herbivores to fierce predators, continued their existence unaware that they were approaching the threshold of the greatest biological catastrophe in the planet's history. We travel back to that fragile age, to see how life flourished, struggled, and ultimately perished in the shadow of the Permian-Triassic Extinction, the greatest die-off Earth has ever endured. To understand the events that shaped this pivotal period, we must first explore the world in which it unfolded. The stage for this drama was set by the mighty supercontinent, Pangea. By the early Permian, Earth's landmasses had fused into a C-shaped colossus. To the north lay Laurasia, to the south, Gondwana. Together, they occupied nearly 1/3 of Earth's surface, surrounded by the vast, lonely ocean of Panthalassa. But this unification came at a cost. The heart of Pangea was far from the sea, cut off from moist coastal air. Over time, climates shifted. The interiors grew scorching hot and dry. Deserts spread endlessly, and rain-dependent habitats shrank into fragile pockets. Forests that had once blanketed the Carboniferous world began to vanish, replaced by dusty plains and arid wilderness. Yet, life never stops adapting. In the crucible of heat and drought, new plants and animals evolved, perfectly crafted for survival in a changing world. This transformation was especially evident among the planet's flora. The old Carboniferous dominants, ferns and lycophytes, could not withstand the growing droughts. As they retreated, conifers and xerophytic seed plants spread across the land. These hardy pioneers could conserve water, endure the heat, and colonize previously lifeless dry regions. The transformation of Earth's flora was not merely a background event, it shaped entire ecosystems. With the arrival of new plants came new herbivores, and with these herbivores came new predators. As food webs shifted, new rulers began to emerge on land. If one group of animals defined the Permian, it was the synapsids, the distant ancestors of mammals. Synapsids began as small, lizard-like creatures, but by the Middle Permian, they rapidly evolved into dominant land vertebrates. The most prominent, the therapsids, marked the first dominance by this lineage on Earth. Among them were the dachinodonts, stocky herbivores with beak-like mouths and, in some species, downward-pointing tusks. They grazed on tough seed plants, spreading across Pangea in herds. In contrast, apex predators, like the gorgonopsians, stalked the woodlands and plains. Some grew to bear-like sizes, armed with saber-like teeth that could pierce through thick hide. For millions of years, they were the unchallenged kings of the Permian food chain. Toward the end of the Permian, another therapsid branch, the cynodonts, emerged. Unlike their bulkier relatives, cynodonts had sharper teeth, better jaw muscles, and possibly even fur. These were mammal-like creatures that hinted at the future rulers of the Earth, the true mammals that would one day evolve from their line. Yet, synapsids were not alone. Their rivals, the sauropsids, ancestors of reptiles, also found opportunities in Pangea's harsher climate. One armored giant, Paraeosaurus, lumbered through dry ecosystems, using its shovel-like teeth to shear fibrous plants. And in the northern regions lived Proterosaurus, a long-necked, agile hunter that resembled a stretched-out lizard. Though not yet dinosaurs, these creatures were paving the way for the great reptilian dynasties to come. While vertebrates battled on land, the insect world thrived with staggering diversity. Some Carboniferous giants, like Arthropleura, a millipede over 2.5 meters long, had already declined. But other arthropods, beetles, roaches, and dragonflies flourished in the changing climates. These tiny architects of ecosystems played silent but vital roles, recycling nutrients, pollinating plants, and providing food for reptiles and synapsids alike. Beneath the waves, ecosystems blossomed. Shallow seas teemed with brachiopods, bivalves, and coral-like organisms. Colorful starfish and spiny sea urchins carpeted the seafloor, while ammonoids, with their coiled shells, drifted above as elegant predators. Ancient sharks prowled the seas, and bony fishes diversified into new niches. For a time, marine ecosystems seemed unshakable, a thriving reflection of life on land. But this balance would not last. A dark curtain was about to fall over both oceans and continents. The Great Dying begins around 252 million years ago. Earth entered its darkest age, and the Permian-Triassic Extinction event, the most catastrophic die-off in our planet's history, was underway. The culprit? A cataclysm of unimaginable scale. In what is now Siberia, colossal volcanic eruptions spewed millions of cubic kilometers of lava. The skies darkened with ash, while immense amounts of carbon dioxide and methane choked the atmosphere. Wildfires ignited forests and coal beds, releasing even more greenhouse gases. Oceans have grown increasingly acidic, losing oxygen in suffocating anoxic events. Global temperatures soared to extremes. Tropical waters reached 40 104°, and the land endured relentless, deadly heat. The toll of extinction. The effects were merciless. In the oceans, 80–90% of marine species vanished. Coral-like organisms, trilobites, and entire families of fish disappeared forever. On land, 70% of vertebrate species are estimated to have perished. Iconic therapsids, such as the gorgonopsians, were wiped out. Even the mighty parasaurs met their end. Insects, usually resilient, suffered their first and only known mass extinction. Ecosystems disintegrated. Food chains broke, and abundance gave way to silence as the Permian world collapsed. Aftermath. Dawn of the Triassic. Still, life, fragile as it is, always finds a way. As the volcanic fury waned, Earth slowly began to heal. The Triassic period dawned, a time of rebirth. Ecosystems took nearly 10 million years to recover, but new creatures emerged from the ruins. Reptiles, better adapted to hot and dry climates, diversified explosively. Among them were the earliest archosaurs, a group that would later give rise to crocodiles, pterosaurs, and the legendary dinosaurs. In the oceans, survivors rebuilt food webs. New marine reptiles, like the sleek ichthyosaurs, evolved into top predators. The Permian extinction irreversibly changed life's course, creating opportunities for new dominant species on land and sea. Closing narration. The Permian period ended in fire and ash, a tragedy unlike anything Earth had ever seen. Yet from this devastation came transformation. The age of synapsids, the ancestors of mammals, gave way to a new era dominated by reptiles. From the ashes of extinction, life reinvented itself, setting the stage for the rise of the dinosaurs and eventually for us. 252 million years ago, life on Earth nearly came to an end. But it did not, and in its survival, we find the greatest story ever written, not of death, but of resilience.